Hello, everybody. It's great to see you here, and it's great that you decided to join us here at this stage to hear about our stories. My name is Jacek, and I'm from O-Ring Company, and I'm really glad that I have this opportunity today to present our interesting, successful story achieved together with Zabbix in the public transportation sector. So today I'm going to show how the public transport operators can really benefit when a great combination of software and hardware is delivered to their project and application, and this will be basically based on their real use case. So let's get started, but before I will jump into the case study, first of all I would like to shortly introduce our company to give you better background about who we are and what we actually do. So O-Ring is a company from Taiwan, and we identify ourselves as industrial networking one-stop solution provider. It means that we have a wide range of products and solutions which enable communication, data transmission in industry-specific application. It means that we can expect some harsh operating environment, completely different that you know, for example, from your households or maybe office space. So our products are used in markets like railway, public transport, intelligent transportation systems, security, energy market, building automation, manufacturing automation, or maybe industrial Internet of Things. As I mentioned, the headquarters is based in Taiwan, in Taipei, but we have branch office all over the world. The one that I represent is from Europe, registered in Germany. When it comes to the company size, we are a small, medium enterprise with a headcount of around 200 people. But what is important, our human resources strategy and investment is focused on R&D capabilities in order to work with the latest technologies, develop new products, and provide excellent technical support. The company was established in 2005, and since then we had a very fast pace of development. These include new product launches, new technologies implementation, new certification. When it comes to the recent years, the company's strategy is focused towards the cybersecurity, which is must-have, I believe, in coming years. Just 2 years ago, we already received a cybersecurity certification. Last year, we joined our forces with industry leader when it comes to cybersecurity solutions, Fortinet. And we also start our story with Zabbix. And since this year, we can actually call ourselves Zabbix partner. So our portfolio of products include all type of hardware devices which can provide total solutions in multiple applications from the field through the edge to the core. So these include Ethernet switches and managed layer 2, layer 3, wireless devices like Wi-Fi access points, 4G, 5G cellular routers, low power WAN gateways, device servers, media converters, a lot of accessories, IOs, and even such specific devices like smart lighting controllers. And because to benefit from the application to use the hardware must usually cooperate with a software. And we as a hardware manufacturer are usually focused on the field and edge layers. Of course, we have some own in-house developed apps that just limited to device configuration, maybe local network monitoring. And then we also cooperate with third-party software providers and open source softwares in order to provide full flexibility and many features for different specific applications. And I think now this is the great moment to share the story of a powerful synergy between O-Ring and Zabbix, synergy between industrial hardware and software. And as you already heard, our story started in Belgium, so let me move on to the case study. So when it comes to the project background, the project owner is a company called Delin. Delin means the line in English, actually. And Delin is a public company which provides public transport services in Flanders, in the north part of Belgium. Company for its operation receives allocation from Flemish government, and of course the second source of income is the sales of the tickets. And just to give you some background about the numbers, 3.5 million passengers uses services every year, and their vehicles made over 10 million of journeys every year. With 8,000 employees, the Lean is one of the biggest employers in the country, and they deploy more than 4,500 public transport vehicles. This includes buses and trams. And of course, long-term goal for the company is to strengthen digital transformation, improve fleet efficiency, and increase customer satisfaction. And the project that we took part in is actually part of a bigger initiative called ITOB. ITOB stands for IT on Board. So basically, the project goal is to deliver more accurate information and hand services to the passenger, thanks to the more modern and easily manageable infrastructure. So the Lean actually targets to improve customer satisfaction and experience by better control over data, better punctuality, seamless connectivity, traffic information, and they also aim to improve passenger security, comfort by wide use of IP cameras, passenger information system, or maybe passenger counting system. But what was the real driving factor when it comes to this specific project? So in Q4 2022, 3 main mobile operators in Belgium announced that by end of this year, by end of 2024, the 3G network will be phased out. And this has a direct impact on daily operation of the vehicles, because all the Lean vehicles are communicating over 3G. So there is an onboard computer which has built-in 3G communication module, and this module cannot be easily upgraded or exchanged without hardware intervention. And the Lean had to face this problem and find a solution, and they have decided for standalone installation of 4G and 5G new radio communication modules, which is the very first step of the ITOB project. And this project also aims to have like an architectural vision for the whole vehicle as a one system, because there is another problem that the Lean is facing. So here you can see the real situation from current status when it comes to the vehicles. You can see that there are a lot of different devices and applications on the vehicle. And these systems are unfortunately not always connected with each other, not integrated, and they use different source of the same information. They have different antennas, etc. So this is creating this kind of silo-orientated architecture where the data exchange happens in parallel and is very problematic. The reason why the Lean, and not only the Lean, ended up in this kind of situation, because other operators can have similar situation, is because, first of all, there was a high focus on project delivery with hard deadlines, so they were focused to put the solutions into production as soon as possible. Secondly, there was no upfront architectural vision for the vehicle IT systems, so they just developed the projects which were delivering the solution by their own. And last but not least, at that point of time, there was really no industry standard which could provide the interoperability and integration. So that resulted with proprietary solutions from many different vendors and project suppliers. So this is actually a system-centric architecture, and the systems are interconnected with each other. So whenever there is a change in one system, this has an effect on the other systems which has to be adjusted or adopted. So you can imagine that this requires a lot of time and resources to be controlled. That's why the Lean is in so-called constant firefighting mode, right? So the new approach will try to change this and migrate the system to a data-centric architecture based on a modern, generally accepted standard. So just to shortly mention, the project is aimed to deliver an IP-based architecture based on a standard called IT4PT. So IT4PT called a crucial role in the project. There is no time really to go deeply into the details, but IT4PT stands for Information Technology for Public Transport. And that's basically a standard which enables interoperability of the data, integration between the devices on board the vehicle. So in the new architecture, all of the assets on board the vehicle will be connected through an IP-based network with shared services like date and time, GNSS. And thanks to the proper implementation of the hardware and software, both in the vehicles and in the back office, the Lean will finally have a chance to control the data, get access to real-time data, and this is the fundamental thing when it comes to improvement of the services to the passenger, the technicians, or maybe even the driver. And here comes information about the project itself. So when it comes to the project rollout, the installation of the 5G modules started already in January this year, with the aim to be finished by end of this year when the actually 3G network will be switched off. The progress right now is pretty good because almost all of the devices have been updated. The project size includes 3,920 buses and 438 trams. And the overall framework for the project was to deliver 5G bus router with specific eMark certification for automotive use, 5G router with EN 5155 certification for railway application, rolling stock application, use IT4PT inventory service as a software part, and what is, I think, most important from this presentation perspective, monitoring and management tool for the 5G router infrastructure. And why is it so crucial to have the monitoring tool in this application? Because once the communication module installed on board the vehicle is not operational, it means that the entire vehicle is not available for the commercial use. That's why the health of the communication modules is hence of utmost importance for the Lean, and they must be able to react almost in real time when something bad happens. So the Lean must be able to manage the assets, manage the software, and manage the incidents centrally from one control room located in the back office. So it requires to have a view on the health of the whole fleet, manage software updates, manage incidents, manage technical interventions efficiently. And of course, the system should allow the Lean to verify where each communication module is located at a given time, just to deploy the service team in the right direction. So this is the slide which actually, where I actually extracted some of the key requirements among others from the real public tender document. So you can see the basic requirements for the monitoring tool, which included overview for communication modules with their last known location, software firmware version, which must be updated every 15 seconds. Overview of the current error codes and configurable definition of an incident. It should allow to control the access and control the authorization level for the staff. Some typical protocol support like SSL, SSH, SNMP. It should provide management API over HTTPS to integrate the system with another platform. It should provide actions for log for the actions performed by the users. And not only monitoring capabilities, but also management tool for software firmware updates and software distribution function. So that's the basic requirement when it comes to the monitoring tool we were supposed to deliver to the project. When it comes to the hardware, we deployed two different devices in this project. One is the IGAR gateway, which is 5G router with eMark certification for the bus. And TDJR is a railway certified router for the tram. When it comes about the nice specification of these products, first of all, full gigabit port support, built-in 5G LTE modem inside, dual SIM for redundancy, a lot of security management, various kind of WAN configuration, quick booting time, what was also important because it's important when the driver turns on the vehicle to get online as soon as possible. But most importantly, what we did, we also implemented Zabbix agent on board on our kernel operating system. When it comes to the specification of the railway router, it's pretty similar. The difference is just the certification for rolling stock. Different form factor and especially the M12 connectors for Ethernet, which are vibration proof. but still the same Zabbix agent on board is available. When it comes to the project architecture, it's a basic one, but still very powerful. So in the vehicle, from the vehicle side, there is this bus control unit, the main PC installed on board, which is responsible for controlling all of the equipment located in the vehicle. This includes the displays, the cameras, driver console, sensors, etc., ticketing machines, for example. And then our router is connected to the PC to enable the 5G communication over a private 5G network with private APN and private SIM card provided by the local mobile operator. So the communication is completely separated from the public network. And from the back office side, we have Zabbix server, which is physically located in customers' premises. And there is a communication between the agent installed in our product and the server, which happens over the 5G network. And from there, the customer can already use Zabbix to create own dashboard, to view the history, to view the trends, and even use the API for big data analytics and integrations with other platforms. So what was the real benefit, our strengths and advantages, and why Zabbix was selected for this project? First of all, Zabbix was already known by the customer because it's used by their IT team for server monitoring. That's the one thing. But the other thing is that, of course, as you know, it's open source, flexible, and very powerful tool. What was also crucial from the technical side is the configurable active and passive mode. This is because of the firewall policy the customer has, because they cannot accept any outgoing traffic from the server. So we can only actually operate in the active mode from the device. What was also an advantage is the reliability and good technical support service, because we cooperated very closely with the customer to deploy the solution. Also very important is the scalability, which is directly related with the auto discovery and device templates, because the customer expected that with this amount of vehicles and new modules, all of them should appear automatically after getting online, right, in the platform. And in the future, the Lean wants to have this scalability in order to add more and more devices with no specific limitations. Zabbix also provides the user management, group management, items management. According to the requirement, the user can set the triggers and problems according to what events they actually want to see and be notified about. It has customizable dashboards, so they are not limited to competitive products which provides just a fixed dashboard with fixed data. They can configure alarms and notifications accordingly. They can use dynamic traps from the device to generate some dynamic events. And last but not least, the scripts allowed us to implement the software distribution function, which works in such a way that if we as a router vendor release any new firmware patch, a firmware file to the customer, or maybe the customer will create a new configuration file because they want to change something. If they put this kind of file on the server, update server, Zabbix can actually monitor the actual version of the firmware in the device, compare it with the version in the server, and actually notify user that there is upgrade necessary, or even perform this kind of update campaign automatically. What are the available device metrics in the device? So basically, first of all, online, offline status, which is the crucial information for the customer. But besides that, we have basic information about the device, which includes the name, serial number, IP address, IDs, version of the firmware and configuration file, GPS position according to the requirement, resources usage, which includes CPU load, system load, memory space, 5G modem and link status, SIM card status, which radio type is currently in use and service provider in use, signal parameters so they can verify the signal quality. They can monitor interfaces, the traffic on the interfaces, including both WAN and LAN interface. And they can use dynamic event reports with Zabbix traps. So on the right side on the screen, you can actually see the actual screenshot from our web interface for the user, where the user can enable the Zabbix traps and select the event types they want to be notified about. Very simple configuration. When it comes to the dashboard, I cannot show the real dashboard from the project, but down the road we made some proof of concepts and demo dashboards. Here you can see an example of device dashboard with the basic information, some status about the modem, the SIM, memory usage, CPU usage with chart with the trends, and the traffic on specific port interface which can be selected. And a general overview of the devices in the system with their location on a map, and of course list of the problems and events which has to be taken care about. So that's all about our project and employment. I hope that was informative. If you have similar stories or similar demand for similar devices, maybe not only in public transport, I will be always around here, so we can all, so I will be happy to have a chat with you and maybe discuss a solution. Thank you so much.